In this topic, we will discuss the derivatives of logarithmic functions. Now, when it comes to derivatives of logarithmic functions, we have two types. One is with respect to base e. The other one is with respect to any base of a. Now, when it comes to base e, we have this natural logarithmic function. And when it comes to any value a, this is logarithmic function. Now, if we will consider any value which is differentiable by x, so we have this as the derivative of the ln of u, the natural logarithmic function of u, with respect to x is equal to 1 over u, so whatever the variable given or function of the logarithmic, and to be multiplied by the derivative of that certain u. For any base a, the derivative of the log of u to any base a with respect to x is just simply 1 over u to be multiplied by a constant of log of e to the base a and then multiplied by the derivative of this u with respect to x. Now, if you will consider that this constant log of e to the base a is also equal to m, so then you can multiply instead the m as 1 over u to be multiplied by m and then multiplied by the derivative of u with respect to x. Or simply, this is also m over u to be multiplied by the derivative of u with respect to x. Now, if we're going to compare with these two, when it comes to natural logarithmic function, there will be no constant value of m. So this is just simply 1 over u to be multiplied by the derivative of the u with respect to x. For the common logarithmic function, there is a constant value which is m, and this is equal to log of e to the base a. So this is simply m over u to be multiplied by the derivative of that function u with respect to x. Now, for our example, so we have this example as we have to look for the derivative of each function. So for number 1, let us discuss. For the given y is equal to ln or ln of 4x minus 1. So understood, this is our u. Then might as well as you have to look first the derivative of this u, and if the u is equal to 4x minus 1, then we can find the derivative of this u as equal to 4. Then just simply for the given function y, this is simply derivative of the function y with respect to x, is now equal to 1 over u, which is 4x minus 1, to be multiplied with the derivative of u, which is equal to 4. And then finally, simplifying the final answer, we can multiply the 1 and 4. So this is just simply that the derivative of this function y with respect to x is equal to 4 over x minus 1. For our example number 2, the given function is y equal to ln of 1 minus 2x, and this is raised to the cube power. Then we can consider this as our u, but this time, finding the derivative of this u, we can apply or we can use the power derivative. So might as well as we have to look first the derivative of this u, so that finding the logarithmic or derivative of the logarithmic function is easier. Now, this is just simply that by means of power derivative, we can bring this exponent or power as 3. And then raised to, this is now 3 minus 1, and this is raised to 2. And then to be multiplied by this derivative of this quantity, which is negative 2. Then we can multiply the 2 and 3, so we have as negative 6 to be multiplied by the quantity 1 minus 2x raised to square. So this is our derivative of this u with respect to x. Therefore, from the given function, we can now find the derivative of this y with respect to x, or if you want to, you can also use the y prime here. So using the derivative of the logarithmic function as 1 over u. So this is 1 over quantity 1 minus 2x cubed. This is our u. And then to be multiplied by the du, which is equal to negative 6 times 1 minus 2x raised to square. And then finally, we have to simplify the final answer. So we can reduce the 1 minus 2x here with the denominator as 1 minus 2x. Then our final answer is reduced as 6 over quantity 1 minus 2x. So this is our first derivative or the derivative of the y with respect to x, which is also expressed as y prime, and this is equal to negative 6 over 1 minus 2x. For our example number 3 is a common logarithmic function, or denoted as log. Then our function given is y equal to log of 3x squared to the base 2. So similarly, we can consider that this is our u, and this is equal to 3x squared, and then might as well as we have to look first the derivative of this u. Then the derivative of this u with respect to x is just simply by power derivative. So bring down 2 times 3, and that will be 6, less 1 from the exponent. So this is now x. Then for the given function y equal to log of 3x squared to the base 2 can now be determined as the derivative of that function y with respect to x is equal to 1 over u, which is 3x squared, and then to be multiplied by the constant value of log of e to the base 2, and then to be multiplied by the du, which is 6x. Then we can simplify this. We can reduce the 6 by 3, and that is 2. And then x over x squared, that will be 1 over x. So then we have that this is now 2 over x to be multiplied by the constant value of log of e to the base 2. Or if you want to, you can also use this as a constant m. So 2 over x times m, or 2m over x, either. And lastly, for our number 4, this is also a logarithmic function wherein we can have now that the given is y equal to log of the square root of x squared plus 1 to the base 5. So similarly, this is our u, which is square root of x squared plus 1. Then, finding the derivative of this u, this is by means of power derivative, wherein this is also means raised to 1/2 for the square root. Then finding the derivative first of this u with respect to x is by power derivative. This will be bring down 1/2, and then the quantity raised to 1/2 minus 1 will be a negative 1/2, and then divided by or multiplied by the derivative of this x squared plus 1, which is 2x. Or we can reduce we can reduce the 2. 2 times 1/2 is 1. Then we can express our derivative of u with respect to x as x over the square root of x squared plus 1. Then for the given function, we can now find the derivative of it as derivative of y, and this is 1 over u to be multiplied by the constant log of e to the base 5, and then multiplying with the derivative of u. This is our derivative of u. And then we can simplify this as multiplying the numerator, so x times 1, and then multiplying the denominators of the same base, so we have to add exponents. Therefore, this is simply x. And then for the denominator part, square of the square root is raised to 1, so this is now x squared plus 1, and then to be multiplied by the constant value of log of e to the base a. Or if you want to, you can also express as x times log of e to the base 5 divided by the x squared plus 1.